In these reflect questions, we're being asked, are the images you drew for each example the same size and shape as the given pre-image? Yes, they were. In what ways do the rigid transformations change the pre-image? They change, or they may change, the orientation of the shape. Does the order in which you apply the transformations make a difference? So test your conjecture by performing the transformations in part B in a different order. All right, so in this part B, if I had done things in a different order, for example, if I had done my reflection first, then it would be here. And here. So that would be A prime. This would still be C. Let's call it C prime for clarity as well. And this would be B prime. So I've done my reflection. So let's do the rotation next. If I rotate C 180 degrees, or C prime, 180 degrees around the point P, here's C double prime. Here would be A double prime, and here would be B double prime. And then finally, if I took those and translated them along the vector V, I'd be moving them 5 spaces to the right and up 1. So 1, 2, 3, 4, 5, and up 1. Here's B triple prime. C double prime goes 1, 2, 3, 4, 5, and then up 1. And A double prime, 1, 2, 3, 4, 5, and up 1. Here's A triple prime. So how does that compare to where it landed in the last example? So if we compare the location of A triple prime, B triple prime, C triple prime, when I changed my order of transformations to where it was originally, we see that the order does matter. So you want to make sure that you are performing these transformations in the order in which it's described to you. So to answer this question, yes, the order does matter. For part B, describe a sequence of transformations that will take A double prime back to the pre-image. It's asking us, what would I have to do to A double prime, B double prime, C double prime in order to land it back at its pre-image? And what I'd hope that you'd realize is that transformations are almost like equations. So think about what you do when you're solving for x. You're doing the opposite of what's been done to x. Similarly here, if I want to get back to my pre-image, I would do the opposite of what had been done. So in the opposite order, of course. So since I'm talking about what I would do to this triangle in order to bring it back to the original, let's go backwards. I would do a translation, not along this vector, but along kind of its opposite vector. Notice the difference. Its magnitude, or its length, is the same, but it's going in exactly the opposite direction. So I would do that translation, and then I would do a 180-degree rotation. So I translate the triangle along a vector opposite of V, and then a 180-degree rotation around P. In this example, we're doing a reflection and then a 90-degree rotation. And again, like the last example that I did here, there's no numbers. So we have to kind of create our own, but we'll get to that. First thing we're doing is taking this triangle and reflecting it over line L. When I do, here will be C prime, here will be A prime, and here will be B prime. To clarify, notice how C is one space to the left of my line of reflection. That means C prime will be one space to the right of it. Similarly, A is 1, 2, 3 spaces on the left of A. That means A prime will be 1, 2, 3 spaces on the right of it. B is one space to the left, B prime is one space to the right. And now from here, I'm going to do a 90-degree rotation around point P. And like I said in the last example, since I don't have any numbers, I'm going to kind of create them. And by doing so, I have to start off by making this point kind of my origin. So I'm going to take this and turn it 90 degrees around point P. So I'm physically turning my paper 90 degrees. And when I do, this C prime would now be at negative 1, 1, 2, 3. So that's where C double prime is going to be with respect to this point. A double prime is at negative 1, 1, 2, 3, 4, 5. B double prime is negative 1, 2, 3, 4, 1, 2, 3. So now I turn my paper back around properly and I plot these points on my actual grid according to where P is normally. Okay, so C would be at negative 1, 1, 2, 3. So this is where C double prime is. A double prime is at negative 1, 5. So here's A double prime. And B double prime is at negative 4, 1, 2, 3, 4, 1, 2, 3. So there's B double prime. And when I connect the dots, that is my final answer after the reflection and rotation. In the next kind of examples, now we're combining non-rigid transformations. So remember that translations, rotations, reflections, these are all rigid transformations, meaning your pre-image will be the same size and shape as your image. Whereas a non-rigid transformation, sometimes it's a dilation. Notice this vocabulary. And when we talk about the word dilation, what we're saying is that it's the same shape, but not necessarily the same size. And when we talk about its factor, sometimes we might see the word scale factor. That's basically what we're multiplying the coordinates by, or eventually the lengths by. Okay, so that scale factor, or that factor, is telling you how much bigger or how much smaller this dilation image will be. So in this example that they've done for you, they started at ABCD, and then they applied a dilation in order to get A prime, B prime, C prime, D prime. You see that on the right side of your screen also. And then they reflected that over the y-axis. You see it now on the left side of your screen here. A double prime, B double prime, C double prime, D double prime. And then finally, the last thing they did was translate it. So that's your final answer on this example. This one here. So let's do one like that. The first transformation is they want us to figure out whether it's a horizontal or vertical stretch by a factor of, and there's a number that they want. So notice what the first transformation is that we're doing. We're multiplying all of our x coordinates by 3 and we're leaving our y coordinates alone. So since it's our x coordinates that we're multiplying and x is a horizontal distinction, it's a horizontal stretch by a factor of 3. So let's apply that stretch. Well, in order to do that, let's identify our coordinates. A is at 0, -2. B is at -2, -4. And C is located at -4, -4. When I apply that stretch, A prime is still here because when I multiply 3 times 0, it's still 0 and I'm leaving the y coordinate the same. B prime is at -6, -4 here. And C prime is at -12, -4. And we label that image naturally, A prime, B prime, C prime. Second transformation is a dilation by a factor of, notice, I'm multiplying the x coordinate and the y coordinate by 1/2, but since it's combined with a reflection, that's why you notice that the y coordinate is also changing signs. Okay, so when I multiply A prime by 1/2 and then I flip the y coordinate over, I get 0, 1. So here's A double prime. B double prime will now be at -3, 2. And C double prime will now be at -6, 2. And I applied that transformation to A prime, B prime, C prime, and I called it A double prime, B double prime, C double prime. If you dilated a figure by a factor of 2, what transformation could you use to return the figure back to its pre-image? Once again, I talked earlier about how you just want to do the opposite of what you had just finished doing. So, dilate with a factor of 1/2. If you dilated a figure by a factor of 2 and then translated it right 2 units, what sequence of transformations would return the figure back to its pre-image? Translate left 2 units, and then dilate with a factor of 1/2. Student is asked to reflect a figure across the y-axis and then vertically stretch the figure by a factor of 2. Describe the effect on the coordinates. Okay, well, we know that the rule for a reflection over the y-axis is this. And if I'm trying to vertically stretch the figure by a factor of 2, that rule would look like this. So how could I take those rules and combine them together to make one transformation rule? It would be xy maps to negative x, comma 2y. The last kind of examples that you're looking at, you're just predicting what's going to happen. So it's saying if triangle LMN is translated along the vector negative 2, comma 3, and then reflected across the y-axis, and then reflected across the x-axis, what would happen to it? Okay, so since this example isn't really doing the transformations, it's just predicting it, you might want to pause and just read their predictions before I go over example 3 part B for you. So square HIJK is rotated 90 degrees clockwise about the origin and then dilated by a factor of 2, and they've given a rule for that. Okay, so the effect of the first transformation is that it will HIJK will be mapped into quadrant 2. The second transformation is to dilate it by a factor of 2. So the effect of that transformation is it's going to stay in quadrant 2, and be twice as big, or twice the size of HIJK. And I think I accidentally answered the last question in this one. Pause the video for the your turn below.